Software is everywhere. It's in our phones, our cars, even our refrigerators. A buggy app isn't just an inconvenience. It can lead to financial losses, security breaches, and even safety hazards. Software quality assurance, or SQA, is the shield that protects us from these risks. At the heart of SQA lies software testing, a critical practice to identify defects and ensure the delivery of a robust and reliable product. Think of a bridge. Before it opens, engineers rigorously test its structural integrity to ensure it can handle the expected traffic load. Similarly, software testing scrutinizes every nook and cranny of an application, ensuring it functions as intended under various conditions. From identifying simple typos to uncovering critical security vulnerabilities, software testing is the unsung hero that guarantees software quality. Black box testing is like interacting with a magic box. You input something and observe the output without knowing the internal workings. It's about evaluating the software's functionality based solely on its inputs and outputs, irrespective of its internal code structure. Imagine testing a music player app. You'd try playing different music formats, creating playlists, adjusting volume, and see if it works as expected. Black box testing is ideal for validating user workflows, ensuring the software meets user requirements, and identifying integration issues between different components. This method is particularly useful when testing large and complex applications where understanding the entire codebase is impractical. It is also valuable for testing third-party integrations where access to source code might not be available. However, black box testing alone cannot uncover all defects, especially those related to specific code implementations or boundary conditions. It's most effective when combined with other testing techniques to achieve comprehensive software quality. If black box testing is about observing the magic show, white box testing is about understanding the magician's secrets. In this approach, testers have access to the source code and can design tests based on the internal structure and logic of the software. Think of a car mechanic diagnosing an engine problem. They don't just observe the car's behavior. They open the hood, examine the engine components, and analyze their interactions to pinpoint the issue. Similarly, white box testing scrutinizes the software's inner workings, allowing testers to design targeted tests covering specific code segments. This method is highly effective in uncovering hidden errors, logic flaws, and security vulnerabilities that might not be detectable through black box testing. By understanding the code's intricacies, testers can design test cases that exercise specific code branches, boundary conditions, and error handling routines. White box testing is particularly valuable for unit testing, where individual modules of code are tested in isolation. It's also crucial for security testing, where understanding the code's vulnerabilities is essential for building secure software. Gray box testing strikes a balance between the black box and white box approaches. Testers have partial knowledge of the software's internal workings, such as access to design documents, database schemas, or API specifications. This knowledge allows them to design more targeted tests than black box testing while avoiding the complexity of full white box testing. Imagine a plumber fixing a leaky faucet. They might not have access to the entire plumbing system's blueprints, but understand the general principles of water flow and fixture connections. Similarly, gray box testing leverages partial system knowledge to design tests that are more comprehensive than black box tests, but less exhaustive than white box tests. This approach is particularly valuable for integration testing, where different software components are tested together to ensure they interact seamlessly. By understanding the interfaces and data flows between components, testers can design tests that expose integration issues effectively. Gray box testing offers a practical compromise between the thoroughness of white box testing and the efficiency of black box testing. Section 5. Beyond the surface functional testing. Functional testing, as its name suggests, focuses on verifying that the software functions as intended. It ensures that all features, from the most basic to the most complex, operate according to the specified requirements. Imagine testing an e-commerce website. Functional testing would involve testing user registration, product search, adding items to the cart, the checkout process, and order confirmation. Each step in these processes would be tested with various inputs and scenarios to ensure they function correctly. Functional testing is critical for ensuring the software meets user expectations and delivers the intended value. This type of testing can be performed using various techniques, including black box, white box, and gray box testing. Regardless of the method, functional testing is an indispensable part of the software development lifecycle, ensuring that the software delivers on its promises and meets the needs of its users. Section 6. Performance, security, usability, non-functional testing. Non-functional testing is like the unsung hero of software quality. While functional testing ensures the software does what it's supposed to, non-functional testing ensures it does it well. This category encompasses a wide range of tests, each focusing on a different aspect of software quality beyond basic functionality. Performance testing, for example, evaluates how the software performs under different load conditions. Security testing identifies vulnerabilities that could be exploited by malicious actors. Usability testing focuses on the user experience, evaluating how easy the software is to use, learn, and navigate. Non-functional testing is crucial for ensuring the software is not only functional, but also reliable, secure, and user-friendly. By identifying and addressing non-functional issues early in the development process, teams can avoid costly rework, improve user satisfaction, and deliver a higher quality product. Section 7. Risk-based testing, prioritizing for impact. In a perfect world, we would have unlimited time and resources to test every aspect of our software. However, in the real world, software development operates under constraints. This is where risk-based testing comes in, a strategic approach to testing that prioritizes testing efforts based on the likelihood and impact of potential defects. Think of it like a triage system in a hospital. Doctors prioritize patients based on the severity of their condition, ensuring those with life-threatening injuries receive immediate attention. Similarly, risk-based testing focuses on identifying and mitigating the most critical risks to the software's functionality, security, or performance. This approach helps teams deliver high-quality software within budget and time constraints, mitigating the most significant risks and ensuring a successful product launch. By focusing on the areas of greatest potential impact, risk-based testing provides a practical and efficient approach to software quality assurance. Section 8. Model-based testing predictions and automation. Model-based testing, or MBT, is a powerful technique that leverages models to design, generate, and execute test cases. These models represent the software's behavior, allowing testers to simulate different scenarios and predict potential issues before they arise. It's like using a flight simulator to test an airplane's performance under various conditions before it takes to the skies. MBT involves creating a model of the software's behavior, using this model to generate test cases, executing these test cases on the actual software, and analyzing the results. This approach offers several advantages over traditional testing methods, including early testing, comprehensive test coverage, and support for test automation. MBT is particularly valuable for testing complex systems with a large number of possible states and transitions. While MBT requires specialized skills and tools, its benefits in terms of early defect detection, increased test coverage, and test automation make it an increasingly popular approach in modern software development. Section 9. The right tool for the job choosing your testing approach. With so many different software testing techniques available, choosing the right one for your project can seem daunting. The key is to select the approach that best aligns with your project's specific needs, goals, and constraints. Factors to consider include the software's complexity, the development methodology used, the project's budget and timeline, and the desired level of testing coverage. For example, a small project with a tight budget might opt for a combination of black box and risk-based testing, focusing on the most critical functionalities and user workflows. A large, complex project, on the other hand, might require a more comprehensive approach, incorporating white box testing, model-based testing, and automated testing frameworks. The key is to strike a balance between thoroughness and efficiency, ensuring adequate testing without jeopardizing the project's timeline or budget. By carefully considering these factors and selecting the right tools for the job, teams can ensure they are effectively testing their software and delivering a high-quality product. Section 10. Conclusion. Software testing, a cornerstone of quality. In the ever-evolving world of software development, one thing remains constant: the importance of quality. Software testing, in all its forms, is the cornerstone of this quality. From the simplest black box tests to the complexity of model-based testing, each technique plays a vital role in ensuring that software is reliable, functional, and secure. The choice of which technique to use depends on a multitude of factors, and the most effective approach often involves a combination of methods tailored to the specific project. Understanding these nuances empowers development teams to make informed decisions about their testing strategies, ensuring they are maximizing their testing efforts and delivering the best possible product. Ultimately, software testing is not just about finding bugs, it's about building trust. By embracing a culture of quality and investing in robust testing practices, we pave the way for a future where software not only meets, but exceeds our expectations.